Alright, number 7, we want to draw the graph of a one-to-one function. The graph of the one-to-one function is given. We want to draw the inverse, f negative 1. Alright, I'm going to do the best I can to kind of sketch this to scale. 1, 2, 3, 4, 5. We don't have anything bigger than 5. 1, 2, 3, 4, 5. So this is x. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Too much of a gap there, but it should be pretty close. So we have the points negative 4, 1, 2, 3, 4, and negative 4. So that's about right here. So this is negative 4, negative 4. And then we have negative 3, 1, 1, 2, 3, up 1. So we have negative 3, 1. And then we have the point 1, 2, right? 1, up 2. So this is 1, 2. And then we have the point 3, 4. 1, 2, 3, 1, 2, 3, 4. So that graph is something like this. Mine is a lot more spread out. Pretty close. Alright, the inverse just swaps the x's and y's. So we're going to replace these with different x and well, the x with the y and the y with the x. Alright, so this one will be the exact same point. So it will still be left 4 and down 4. That same point will just overlap. Alright, this one, however, would switch. Instead of negative 3, 1, it would be 1, negative 3. So I would go 1 and then 1, 2, 3. So my next point would go out this way. So that would be 1, negative 3. You switch the x and y, but inverse. This one is 1, 2, so it will be 2, 1. 1, 2, and up 1. So then it would go up this way. And then this ordered pair is 2, 1. And then the last pair, 3, 4, would switch to 4, 3. 1, 2, 3, 4. 1, 2, 3. And that would be 4, 3. And what you get is kind of like a mirror image across the line y equals x. If you drew a line right down the axis, that's kind of what they're showing. So your mirror image just kind of reflects. Now, I'm not the greatest artist, but it looks pretty close to a mirror image across that line. So the graph that matches, let me try to make this bigger. The graph that matches, it's still kind of hard to see. The image, these definitely don't look right. The graph that matches looks close to be C. So we're going to select C for that mirror image. Alright, number 8, we want to consider these functions f and g, and we're going to find f of g of x, we're going to find g of f of x, and then we're going to determine whether the functions f and g are inverses of each other. Okay, so what this means, we're going to start with the f equation, and we're going to plug the g equation in for x. That's what this notation means. All right. So the f equation is 5x minus 5. So I'm going to start with 5, and then instead of x, I'm going to do parentheses 5, that's x, and then minus 5. Now, in place of x, we're going to be replacing it with the whole g equation, this right here. So 1 divided by 5, 1 divided by 5, and then x plus 5. Alright, so solving this, we would multiply by 5 times 5 divided by 5. That cancels each other out. They divide each other out. So we're just left with x plus 5 minus 5. x plus 5 minus 5. The positive 5, negative 5 divide each other or cancel each other out, and you're just left with x. Alright, so when you plug in something that tells you that those are inverses, and it comes out to be x. So now we're going to do the same thing with the g. Alright, so g of f of x means we're going to start with the g equation. Everywhere we have an x, we're going to replace it with the f. Alright, so the g equation is 1 over 5, and then in parentheses we have an x, which I'm going to open up parentheses for the x value, and then we got plus 5 and close parentheses. So we got x plus 5 in parentheses. Now the f equation is 5x minus 5. So in here, 5x minus 5. That's where x would have been. Replace it with the f equation. Alright, so now what we have to do is distribute 1/5 times this and 1/5 times this. Alright, so that means 1 over 5 times 5x minus 5, and then we also have plus 1 over 5 times this 5. Alright, so when we distribute 1 5 amongst both of these, it's going to cancel out the 5. So we'll end up with x minus 1, or you just divide by 5. The 5 divides. Alright, and then 1 over 5 times 5 plus 1. Minus 1 plus 1 go to 0. So that just leaves us with x. Okay, so they both give us x when we plug them in, so we can definitely say that they're going to be inverses of each other. So f of g of x gives us x. X cannot be. So we want to look at the domain. So in this expression, there are no restrictions, and there were no restrictions when we plugged in g. And when I say no restrictions, there were no fractions with x in the bottom. There's no square roots out of these. So we have a fraction with 5 on the bottom, that's okay. And then at the final, x has no restrictions. So our domain has no values to be excluded. Okay, everything works. Alright, g of f of x, which we've done, gives us x as well. And then same scenario, there were no fractions, no square roots to deal with, and in our final answer we don't have either. So our domain has no values to exclude. Like, everything will work. And then part C, determine are these two functions inverses of each other. Okay, yes, and the way we know is because when you plug it in, if you get x, so you take one function, you plug in a new one, if it ends up being x, which is just this line right here, okay, just the y equals x line from the previous problem, then that means they're inverses of each other. That's the definition. So yes, these two guys are inverses of each other.